So I hope everybody had a nice drink. Well, I'm going to do this subject just like at a Bitcoin conference, which was a different subject, bit message, but I did it without paper. You know, before I presented with a little bit of paper, and it was always good for me to. But at the conference I did a loose presentation, which I actually kind of liked, so I'm going to try that again. It might not be as good as the last one, but it may be. We'll just have to find out. And I'm going to talk about Ethereum. Who has already downloaded and compiled Ethereum or read the white paper?
Wow.
It's an OR construction, so you can raise your hand if you've done either one of those. That's great, because I'm not Vitalik Buterin, who's the main programmer of Ethereum and the one who made it up. And so if I would have had a lot of Vitaliks right in front of me, it would have been rather difficult to tell you anything new. So this is good, we can explore the subject. Oh, that's pretty cool. This is Ethereum. They also have a very nice logo, as you can see. And well, first of all, a good question to start with is, what is Ethereum? Most of you might already know this. If you visited the website, they have some summary information of what it is and what it's good for. But I'm going to tell you anyways, just to get into the subject. And first of all, Ethereum is a smart contract system. And it's also an application framework. So it can run code and create contracts between people or between actors. Furthermore, it runs it on a blockchain, and later on I'll tell you why and how. And it's designed to be a foundation of innovation. And these are all things you can also read on the website. But it's a lot of information in very small sentences, because it's a very accurate description of what Ethereum is. But it also means a lot more than what you first see in those words. So a good question is, well, we already have Bitcoin, we have many altcoins, and they're all great, you know. We even have funny coins, and it's terrific. But why do we need yet another coin or another system next to it? Because also we have Next, which is also trying to re-implement all these interesting ideas for cryptocurrencies. So why Ethereum? Well, the current coins, and that means every single 300 plus of them, is not complex enough to do what Ethereum does, or what it wants to do. And that is, it's made to dynamically implement smart contracts. Now some people might say, but Bitcoin does smart contracts. I mean, I can put some Bitcoins down in escrow and it can be paid out at a later time. And yes, it's true that Bitcoin does have some of those possibilities. So Bitcoin is in a way also scriptable, but not at all as scriptable as Ethereum is. So Bitcoin scripting is great. It can probably be used for interesting contract constructions in the future, but it will not be way enough to create an entire economy out of, next to just being a complex banking system. So we want more, of course, and how are we going to do that? Well, Bitcoin only has auction systems that can be done on the blockchain, and the developers are probably working very hard right now to expand it. But Bitcoin started from a certain point where it was intended to replace basically a centralized bank or store of money, and be a decentralized exchange system of value. And so it was never intended to be a complete contract system. At least it doesn't look like that when you look at the code. So it has no advanced data processing capabilities, and neither do any of the other cryptocurrencies. Well, maybe NXT is one exception, Next, because it's also programmed on a very different code base. But some people have criticized Next for having code that is not as structured as they want it to be for complex contracts. So, okay, Ethereum sounds great, you know, we have a new system, but how does it work? Well, first of all, just like Bitmessage, just like Bitcoin, it does bootstrapping, and you have a decentralized network. And I won't get into the details of that, because basically everybody already has a bit of an inkling of what that's about. It means that you don't need to run a centralized application somewhere on a big server, but everybody can just run a little program on their computer, and that creates a completely decentralized network that is very difficult to take down. But Ethereum also, just like cryptocurrencies, uses a unit of exchange, and this is in Ethereum called Ether. So where in the Dogecoin you have the Dogis that you can pay each other, or in Bitcoin you have Satoshis, in Ethereum you have Ether. And there's different amounts of Ether that also have different names. And if you go to the Ethereum website, you can see that. I don't know them off the top of my head, so I'll just stick to Ether for now. It also has something that is called a Turing complete scripting language. Now, what that is that Ethereum can actually run code. And that's something different than what Bitcoin does. Bitcoin makes it possible to just pay each other certain amounts of value, or have them paid at a bit later date. So that's a tiny bit of scripting there, but mostly it's just used as an exchange of value. Ethereum, on the other hand, can actually run code that can change the behavior of how that value is paid out, to whom, at what time, and under which conditions. And that's what makes Ethereum a project that has a lot of promise for automated accounting and automated notary functions. So how does it do that? Well, it uses something that is called Merkel Trees. And I dug around in that, in those concepts, which are mostly about cryptography. And Merkel Trees are a way to create parent-child relationships in cryptography that make it provable that a certain tree or a branch of information belongs to a certain parent, and that parent actually belongs to a certain uncle, etc., etc. Now, who's not following what I'm telling right here? Because it might be a bit too far out. Okay. So let's say I tell one of the people in the room here a secret. And that person whispers that secret on to the next person, but each time you don't whisper it like Chinese whispers, in the sense that the game ends with somebody saying something completely different, but you also whisper something by which the other person can completely remember what you've been saying. And that looks a little bit like passing information down through a hash tree from one hash to the next. But in this case, you are also whispering to someone something that makes it possible for the person down the line to prove that you are the first whisperer. So in that way, you don't need the entire tree to prove that certain of the parts of the tree are correct. Now, why is that handy? Because in Bitcoin right now, you have to take along an entire blockchain to be able to operate the Bitcoin client as it was intended. And that is how you can prove that the entire economy is financially sound and intact. And you need that entire tree to prove that your transactions are worthwhile and that they have the value that they claim. Because that value came down from some part of the tree at the top and trickled all the way down to you. And you create new branches on that tree while you're paying other people and creating transactions. In Ethereum, passing the entire blockchain is not actually necessary. It is, of course, something that we prefer, because an entire blockchain proves most of all that all these transactions are correct. But at times it might be handy to only have part of the blockchain, or also to be able to prove that certain contract constructions are workable, even though you don't have the luxury of calculating up the entire tree to see if that's true. So Merkel constructions are used to create sub-branches that have a proven top, and that top doesn't need the entire blockchain to be proof. It's like going to the bank and saying, can I deposit my money here? And because they have a big name, for example, Rabobank, that they say, sure, you can deposit it here, and because you know that their name is more or less trustworthy, you deposit your money there. Well, if you go to Zonky Bank and say, well, Zonky Bank, do you want to take my money? And they say, yeah, sure, we'll take your money. And they take it. But you haven't actually done your due diligence. You might have just deposited your money at a bank where you'll never see it again.
Like
and so
Rabobank.
this what did you say?
Like Rabobank, I said.
Like Rabobank, yeah. I just named them as an example because most people would trust the Rabobank. but it could happen to any bank. But in this case, they have a kind of proof, or they claim to have a kind of proof that they're trustworthy by saying, well, our name is also enlisted in, what are those people called that check out the AAA ratings and stuff? Yeah. Moody's, for example. Standards and Poor's. And these guys become actually really rich by writing down these names. But what they're actually doing is they're proving that these institutions are more or less trustworthy and that they can be held accountable to what they're doing with your money. Well, in the Ethereum system, we want to do the same thing, because otherwise people can start creating ether out of thin air. In Bitcoin, we want to do the same thing. So the solution for Bitcoin was to create the blockchain. But in Ethereum, yes, there is also a blockchain, but why not use that all the time? Well, the reason is that if you're running code on the blockchain, and that code needs computing cycles, sometimes to prove a certain value is there, or a certain action has to be taken, you have to run the code decentralized on all these people's computers. And some computers are simply not powerful enough to be looking through the entire blockchain to try and prove the value of a certain transaction. And so to make sure that that can still be done on also slower computers that don't have that ultimate power, they created the Merkel tree construction so that it can calculate up the tree to a certain point and say, okay, from here on, this hash has such a value that we know that the entire rest of the tree is trustworthy, that we don't need to go through the entire tree, because that would only cost a lot of computing time, which would be wasted on doing the same thing over and over and over again for the same contracts. Here you can see a tree where one of these proofs does not make sense, and there that contract would be destroyed. So it's just a small picture as an example. So those are Merkel trees. I won't go further into that because it can be kind of mind-boggling, and it would take a lot of time to really understand exactly how it works. But this was just a global overview of what Merkel trees are good for. Well, what else is something that makes Ethereum work the way it does? It's just like Bitcoin, they have a persistent storage of data on the blockchain. So yes, the Merkel trees are used to prove things, but sometimes you just have to store the actual data. For example, if somebody created a contract, an automatic contract, and wants to store that in the Ethereum blockchain, you need storage space, and that storage space is allocated in the blockchain. Where Bitcoin only stores how much money everybody has, Ethereum stores not just how much ether everybody has, but also how the contracts that regulate that ether are made up, and what they do, and their memory contents. This is something that is probably not too hard to understand for programmers, but for people that don't do programming, it could be a bit difficult. So it could be comparable to just saying, okay, the blockchain is a house, and in that house there are certain places for people to put things. But in Ethereum, these places have extra storage space so that you can store more than just a few coins in certain places, but you can also store contracts and other information. Well, so let's say you want to execute some code, and you write your contract, and it has to be done in a kind of programming language right now, which I'll later show an example of. And you just start running that code. Let's say you write a very interesting virus because you want to try and steal as much ether from people as you can. That virus will probably have to run many times on the blockchain to be able to get a chance to break into somebody's account or try to brute force something. Now you could try and do that to try and game the system, but to protect against that, the programmers of Ethereum have defined that transactions or executing a contract, like executing the code of a contract, can cost you ether. Now the first 16 steps in a contract don't cost you anything. That means very tiny contracts can be run for free because they won't be stressing the decentralized network. But big and complex contracts, for example, if you want to run an entire company in Ethereum, which you could probably do, you write a whole set of contracts that communicate with each other. They'll probably need more than 16 sequential iterations before finishing the programming code of the contract. And so after the 16th step, these steps start costing a little bit of money so that you don't start running huge pieces of code and try and stress the network, and basically everybody has to just give you their computing time to do that. So to keep it fair, they've put a cost to that. The cost actually is paid to also the miners of Ethereum, because they're keeping their computers on to support the network all the time, and they're also crunching these contracts and these codes. Next to that, they're mining hashes for Ether. Okay, well, there's certain design principles of Ethereum, and they're important to consider. So we've just gotten a bit nitty-gritty to the difficult parts. But to step back and take a bit more of a helicopter view, I want to look at the design principles. And these are also things that you can see in the little film that Ethereum has on their website. And the principles are, first of all, simplicity. So what Mr. Dietrich was looking for was not creating a cryptocurrency with a whole bunch of interesting features, but he wanted to keep it very simple, because he wanted to create a foundation for new innovation. So he actually removed a lot of features and said, okay, Ethereum can basically only do two things. First of all, it's an exchange of value like Bitcoin. Or actually that's second of all, because first of all, he said, it's a decentralized blockchain that can run applications and contracts. So he tried to keep it as simple as that, and the rest has all has to be built on top of that framework. And it's not something that's going to get just stuck into the Ethereum code. What he was also looking for was universality. So he didn't want to make an interesting cryptocurrency that had a certain function, like Namecoin, that tries to be a DNS. But he said, no, I want it to be universal, so that people can just build anything on top of it. And it doesn't just have one function, but it can have a myriad of functions, whatever you want. If you can build it, you can make it. And you can make it on top of the framework. So for that reason, he also made Ethereum modular. And that means it's easy to build plugins for it that can hook onto the system. And it's also easy to create contracts that can actually even construct other contracts, so that you can program programming language that can create its own code. And that means that you could create a corporation that can create new rules based on certain events. I'll name some practical examples in a moment. For the rest, he was looking for agility, which means he wanted to make it that Ethereum can be swayed and moved in necessary directions if it's needed. So if they find a certain mistake in the code, they want the code to be agile enough to be able to rewrite it without actually disrupting the entire network. And that means standards that are very, very basic, and trying to find principles that are very open. Like, for example, if we have to name a law example, we have in the world the certain laws laid down at the UN for human rights. And those, they try to keep those very simple on purpose, so that they are quite universal, that they don't rule out certain cultures. In this case, they put the agility in the functionality of Ethereum and in the code, so that it can be changed at any moment. For the rest, it's also attempted to be non-discriminative, and with that they mean that if you want to write code that does something perhaps very stupid, you're still allowed to do so. So let's say I'm a beginner in Ethereum and I write a little bit of code that does nothing but send people a message saying hello, and then returns to the top and just runs that same code over and over and over again. A never-ending loop. Now, in theory, if you run that on the Ethereum blockchain, you'll be destroying the network, because everybody's going to start running that loop, and everybody's going to be calculating just for that little bit of code, which is basically doing something useless. Well, to counter that, we have, of course, the cost of 16 steps of code, which means that after 16 steps, it's going to cost me a lot of money to be doing something really stupid. But next to that, it has been put in the design that it is possible, because being discriminative and saying, well, you can't run that kind of code, but you can run this kind of code, will be forcing people to write things in a certain way. And that's not what they had intended Ethereum to be. They wanted it to be an open platform. So yes, there are rules and limits, but they're imposed on by the economy itself and not by the Ethereum interpreter. I put the title here, I just typed it out because I was not finished with my presentation when I was sitting here. So this last bit I just quickly put together. But I found this picture 2 days ago, and I thought it was a very nice picture. It shows a very big view of where Ethereum is right now in the, what I call, cryptosphere. Maybe it's not a real word, but then I hope from now on it is. Ethereum in the cryptosphere, which is also the cryptocurrency ecosystem. And, well, in this picture it's nicely put in the center, so perhaps it might be a little bit biased, but if we look beyond the bias and just look at the functionality, we can see here that Bitcoin, for example, is put in a place where it shows that it has a proof of work, which people that have studied Bitcoin a little bit already know about. It also has its own independent blockchain. It does not have proof of stake, for example, because it's not a currency that is like a stock, like Peercoin. And at the same time, it is a crypto ledger, which is the very, very big circle in the back. So that's where we see where Bitcoin is. And you can see for all these cryptocurrencies and also all these concepts, and not all cryptocurrencies are listed here, but a lot of interesting new concepts are listed. You can see how they, basically where they merge or where they diverge, and it gives you a bit of an overview of what's going on. Let me see if I can find, oh yes, NXT and BitShares. See that one up there? That was an interesting one. When NXT was launched, it was claimed that this was going to be the cryptocurrency that would change the entire world. It was Bitcoin 2.0, and everybody had to, well, basically, if it was up to the next developers, it would be great if everybody just left Bitcoin where it was. It was the Napster, and NXT would bring in the new age of super cryptos. Well, it didn't go that fast, and here we can also see why. Because NXT does have a next generation platform, so it does support smart contracts functionality, and also it has a crypto ledger. It has proof of stake, which was for a while seen as something very positive, and maybe still is, because it doesn't need such computing power to generate new coins. So a lot of great things going for it. But it was also missing something. It didn't have a real scripting language, which means the developers had a lot of power of what was going to be in NXT. And the developers could define where it's going to go. And basically by sticking as many features onto this crypto currency as they can, they're trying to create a big, from a code perspective, a big Frankenstein that can do it all. Which for some people might be an attractive idea. However, I think if you look at the universality aspect, which Bitcoin does have as well in itself, being a completely new idea, I think that NXT doesn't quite fit the bill. But this is just my personal opinion, so if you're a lover of NXT, then please don't leave it because of my opinion. I think that every crypto should have its place in the market. So Ethereum is at the center at that moment right there, basically because it's where all these lines are converging. And it has the Turing-complete scripting language. As you can see, Ripple also does. Ripple had a lot of criticism going for it, because it was actually so different. It didn't employ a blockchain, and it was a very different way to communicate these coins. And it hasn't become very popular yet like Bitcoin, so it's also vying for its own niche in the market. But Ethereum, even before having been launched, already has a lot of interest of people. And why? Well, I think it's because in many ways, seen from a practical perspective, it is creating something completely new like Bitcoin is doing. And also it's not claiming to be a replacement for Bitcoin like many cryptocurrencies have tried to do. It's basically claiming to create a new piece of economy that can work together with Bitcoin and next to it. and that can enrich the cryptosphere, as it were. Then, what are the practical applications with what can you do with Ethereum in a real practical sense? Well, one of the first things many people will say is, yeah, decentralized exchanges, because people are getting very annoyed at the fact that they're putting a lot of their money on these exchanges, they're throwing it in there, starting to trade some coins, and then all of a sudden the next day they're saying, oh sorry, we got hacked, and we lost maybe 30% of the coins, so we're doing X, which can be any action. Mt. Gox says, we've just taken your coins. Virturex says, we've frozen your coins, you're going to get them back really slowly. And others say, well, we'll just chop off 30% right here and we'll keep going and make the best of it. Poloniex, anyone. So a decentralized exchange, many people want that because it takes the human error out of the equation and the hackability. At least that's what we hope. It is possible with Ethereum. However, we'll probably have to employ something which is called proof of burn. That means that when you create value in Ethereum, that you have to prove that you actually burned the same amount of value in crypto coins. Now, I'm not going to completely explain what proof of burn is because that would take a while. It's not very complex, but for people that don't do much with cryptos yet or that are still beginning in these things, it would take a lot of time to get all these concepts right. So if you want to know more about proof of burn, just look it up. Also look at proof of stake, proof of work, and it will give you an idea. But by utilizing proof of burn, we could actually put value into the Ethereum system and then create, for example, Bitcoins or Litecoins as a kind of equalized stock. And in that way, a decentralized exchange would be possible. I still am a bit skeptical about this idea because I think it would take a while to get this right. And it will take some experimentation where maybe mistakes will again be made. But if we can get it done, is it okay if I answer questions a bit later?
Yeah.
Or is it something, if you don't
It's really
understand?
about decentralized exchange, but...
Okay. So if we can get this done, a really decentralized exchange, then yes, it might have a lot of positive consequences, because then the contracts for Ethereum could automatically deduct a little bit of Ether for each exchange, i.e. the payments are automatically done. These will be paid to the miners, and you can have no scammers that just walk off with your money or get hacked. And so that's a positive thing. But I think we're still a little ways from getting there. It's going to be a difficult thing to achieve. Another thing we could do is crypto stocks. Now, there's also another coin or cryptocurrency that has attempted at doing this, and that one is called Counterparty. That one's already functioning, and it actually can issue crypto stocks, and it's working. So that's great, but Counterparty does not employ a scripting language on top of its platform. So crypto stocks is just about the only thing that it reliably does. And it does enable a new type of trade, also escrow trading, which is very good, and I hope Counterparty continues to develop that. But it won't be able to go as far as Ethereum in that sense. So crypto stocks is also a possibility to run on this blockchain. Derivatives. Now many people don't like that word, and personally I don't either. But derivatives, very true to their original idea, don't have to be as destructive as they often are in real life. And it's often that when derivatives are stacked on top of each other as financial instruments, you're basically creating a house of cards, and the higher it gets, the more brittle. But the same could be said for the stock system that we have right now. I mean, if you buy a stock in, let's say, Nike or Coca-Cola, who actually personally talks to these people? Nobody does. You just buy a stock with your bank and you hope that your bank is doing everything the way it should do. And basically there's no personal communication at all. While in crypto stocks at the moment, you still often see that people issuing the stock write personal letters to the people that have invested in the stock, and they're saying how it's going, and if you write them an email, they'll respond to you. So it's a much more personal way of dealing with each other. I think writing derivative contracts could work, and as long as they're not made or not stacked up too high, I believe that that could also be a possibility to create financial instruments that are handy. Well, some people have suggested peer-to-peer lotteries. The ones that are there right now, which are centralized, also work. But why not peer-to-peer lotteries? If it can be done, it's fun. And then, of course, there's also a good use for reputation mechanisms. There are certain coins, like memory coin, for example, or memory coin 2.0, to be precise, that can actually have people vote. And then you can vote if you want somebody to lead a certain company, or you could even vote if you want somebody to be president of the United States. And you can vote for those people in memory coins. And the memory blockchain will remember those votes, and it makes it possible to retrieve the totals and find out that who was more or less crypto-democratically elected. So, interesting. Now, the same thing can be done in Ethereum, but then you build the reputation mechanism in a contract. So you can build it yourself. And you can build different types. So you couldn't just build a democratic reputation mechanism, but maybe a communist one, maybe an anarchist one, or any other type of reputation mechanism. And because of the flexibility of Ethereum, that's all possible. And finally, last but definitely not least, most often talked about, DAOs, Distributed Autonomous Organizations. Let's say you want to have a service in which you employ taxi drivers, and you want taxi drivers to take to different places for cryptocurrency. You could create a DAO for that in Ethereum. Basically, the taxi driver has an Ethereum wallet, and he says, yes, I want to be part of that contract, so he sends a small transaction to that contract. It's a very small, insignificant transaction, which only means that he's signing up for your contract. And then your contract automatically tells the taxi driver, okay, we still need taxi drivers in Amsterdam, for example, because the contract can automatically calculate where taxi drivers are necessary. Next, the taxi driver receives his instructions of where he can drive around for cryptocurrency. And each time he does a transaction, he sends that transaction to the Ethereum blockchain, where the contract automatically calculates how much of that money goes to the taxi repair service that will repair his taxi, and how much he can keep himself as a wage for his services. In this whole organization, we haven't needed actually a single person beyond the taxi driver to arrange these things, and maybe the repairman that wants to repair the taxis, but that's it. So it's a bottom-up organization that is completely controlled through the Ethereum contract and blockchain system. So what does this thing look like if you write a contract? You know, what are you supposed to expect? Bye-bye. This is an example of a very small contract. And it's often been said by the Ethereum developers that this is the contract for a Namecoin functionality. So they said, yeah, you don't need Namecoin, because look, in just a few lines of code, we've replicated Namecoin. Which I think is not entirely true. It's a good way to make PR for your own system, for Ethereum. And yes, Ethereum can implement Namecoin, no doubt about that. But in these just few lines of code, I don't think the entire Namecoin protocol has actually been implemented, because we're not counting the DNS system itself that Namecoin also has as a feature programmed onto itself. So that should be added onto Ethereum as a plugin. We're also not counting the fact that a Namecoin has to have certain DNS hosters that will host that DNS. And that also has not been implemented in these few lines of code. So yes, the basic concept has been put down here, and I'll in a moment explain what the code does. But Namecoin in its entirety has not been put down in an Ethereum contract. So we have to be a bit truthful here. Yes, it can be done, but it hasn't been done quite yet, and not quite completely. And so this is a nice example to see what a contract looks like, but it's definitely not the final example, and there are way bigger contracts that can be made that will actually do a lot more. Okay, first of all, you can see these double slashes on certain lines here, 3 lines, where it says exited a transaction value too low, blah, blah, blah. Basically, in this code, it means that the contract system ignores those lines. Those are just comments for the programmers themselves to know what each part does. So, first of all, we see on the second line that we have a little bit of code saying if tx.value is smaller than block.base fee times 200, return. Now what they're doing with that first little block of code is that they're checking, is there enough ether to run this contract? And if there isn't, just stop right there. Don't continue. Also, has enough money been sent to the contract to run it? And if there hasn't, then why continue? Because then you're just wasting people's computing time. So after that little part, we go to the next part. And it says if contract.storage, and then it opens a collector for arrays, tx.data 0 and close, return. So it's there checking if storage for a certain name, in which would be the name coin system, a certain DNS registration, is already used. If it is, then nothing happens. But if it's still free, then a name can be stored in there. So you can actually attach a name to a value. And that is what usually people do when they are, for example, writing a real life contract for you. For example, if you want to register your company in Holland, you do that at the KVK, Kamer van Koophandel. And there they will write a contract for you and you have to pay them cash for that. Don't know why, but because it's just a little bit of writing, but you do. And then they'll write it down in a kind of ledger that everybody can check, so that everybody can see you are a legal company in the Netherlands. Basically, that is the blockchain of the Kamer van Koophandel. That is their ledger, that you're written in there, and they just add people onto that blockchain. It's getting quite big, and sometimes people are kind of striped off of it as well, because there's also companies that don't make it. But basically, it's comparable. So in this case, we need storage to store a certain name attached to a certain value. And it checks, is that storage space available? No? Okay, stop contract, because we don't want to waste people's time. Then in the end, we have, if there is space to store a name, then it's being done in that last line of code. Contract.storage txdata0 equals txdata1. So in the space of sending Ethereum a contract with some value attached to run the contract, you're sending it a value and some data. It checks if it can store the data, if there's enough value to store the data, and if so, it stores the data in contract.storage txdata0. Now, if you didn't follow everything of this, it's okay, because this is still quite new, and also this is programming language which is not everybody's thing. But I was just wanting to give you a gist of what a contract looks like, and for those who know a little bit of programming language, you can see that it looks a little bit like the programming language called C, which is a very well-known programming language. Now, let's say you want to just go play, and you want to say, okay, I like this, I want to write some contracts, I want to just test this thing out. You know, where is Ethereum? Where can I buy it? Where can I run it? Well, sad to say, it's not running in real life yet. It's now running in a testing phase. So that means the ether in the test blockchain is not yet for real. It doesn't hold a real value. At least that's what people agree together at this moment. So before Ethereum is ready to run with real ether, will probably be a few months down the road. And right now, testing is being done. But also in testing, you can already write test contracts. And the fun thing about that is, it won't cost you any money to run these contracts and just develop your own contract. To save you the hassle of downloading it and having to compile Ethereum and the code, which is a lot of work, you could also go to this web address, kinoko.github.io/Ethereum-simulator. And it's a small simulating arena in which you can just look at these contracts that are already there. Actually, I'm going to show it to you. It looks kind of cool. Let me pick it up. So as you can see, it looks really nicely green and black, and it gives that good old feeling of the 80s and 90s coming right back at you. Hercules monitors, and well, those people who were hacking behind their little IBM PCs in those days still remember this. So there's a lot of nostalgia there. But apart from the nostalgia and the beautifully punk purple, we can see here, actually the other side is not quite visible. Let me see if I can show that to you as well.
Yeah, it's great.
De gordijnen worden zometeen
Okay.
groter.
Oh, that's great. Yeah, yeah. Then I'll just put it back to full screen. So this is a playground. It might not look very child-friendly, but it's a playground, and you can play in it. And so, if you like, you can go to this webpage, and there are several things you can click on. So, because you don't have to type everything these days, you know, you can also click on things. One of the things you can click on is here, this block, create Namecoin, or this block, which is wallet to Namecoin, run Namecoin, or this block, create Cryptsy feed. Now, I suggest you start simply with create Namecoin, and if you click on that, you can see. Actually, I'll do that right now, just for the fun of it. Look at that. That's the code. The code we just saw, and this is the code that runs the Namecoin contract in Ethereum. And you can actually just hack around with it, change it a little bit, see what it does. Maybe you'll change it that nothing works, but that's okay, because this is a playground. You can do anything. It won't cost you any money, and just invite you to play around. And what you can do is try and send value to it, or send data to it, and see what the contract does. And you can reprogram the contract a little bit, and then send value and data to it again, and see what it does at that time. Now, what could you make with that? Well, a whole lot of interesting stuff. Let's say, for example, in the future, you want to run a biological farm, and you want to do it in such a way that that money management is almost automatic. Well, you could say, okay, we'll let the farmers and workers be paid in Ether, and we'll just get, let's say, 200,000 euros and turn that into Ether, and everybody's going to be paying each other with Ether for food and also for housing. And then what you could do is have a weather station check out the weather every so many days. And that weather is turned basically into data. And that data is something that the contracts can understand. So these contracts can actually be watching the weather. And if it starts to get real dry, and in that way there's a lot of chance that the crops are going to fail, these contracts can send extra Ether to the farmers and workers to give them, to enable them to buy more water to water their land, or buy more lemonade to feel better and, you know, not be so sad. So there's a lot of possibilities there. So that's one of the things you can do with an Ethereum contract. Okay, let me get back to the presentation thing. But that was it. So, end of the presentation. So I think that gives a little bit of an overview of what Ethereum is, where it's going, and what it can do. And now, are there questions?
Yeah, I have one question, another question that I raised my hand for. What about scalability? You told that it's possible to put data into the blockchain, and some people are worried about that the blockchain gets too big because you can put the data directly on the blockchain.
Yeah.
Do you know anything about how far they are with solving that issue?
That is an issue for all blockchains as well, but especially for ones that store data.
Mm.
And there is another coin that also has a problem with data storage, and it's called Datacoin. Surprise, surprise.
Mm-hmm.
And it enables storage of all kinds of data in that blockchain. That costs a little bit of data coins. So there's people that think, hey, that's great, let's store entire books and collections in there. And of course that's not going to work, because people will have exploding blockchains that will take much too much space to store. Now, Datacoin will actually have much more trouble with that if they become more popular, Ethereum, however, will probably not have as much trouble because of the Merkel tree construction that I mentioned earlier. So what they can actually do in the future is chop off parts of the blockchain and have a Merkel tree proof above that, which proves that the structure, the structure that lies above the branches is correct. But as long as they're not needed for contract calculation, you can just leave them there, and not everybody needs to store all these tree constructions.
Could you compare that with the bloom filtering which is being used by multibit?
Actually, I have no idea because I'd have to research that first before I can say that. But I suspect it has similarities.
Multibit doesn't download the whole blockchain, but only the 10 first and the 10 last transactions between your transaction, to say it like that, or surrounding your transaction.
Yeah.
And that way it proves somehow that your transaction really happened.
Yeah.
So it sounds a little bit like this, but in another way.
I think it's the same concept. They want to save space and make sure that not everybody has to have an entire blockchain. Yeah. But I don't know if they use the same method.
So, like a contract, when it executes, it reads data. It reads it from the blockchain.
Yeah.
And then, if you wanted to execute a contract on your machine locally, you would download only the blocks where the data would reside that that contract needs.
Yeah, and that's also already something that the contract has predefined, where it will read and where it will write.
Okay.
And so, even before a contract is propagated through the blockchains of everybody, the corresponding data will be given along with it, because otherwise you cannot run it on somebody's computer. So yes, the data that belongs to a contract always travels with the contract. Actually, to be more specific, a contract is stored in a little bit of memory, as it were, or a little bit of data storage inside the blockchain, right? But that memory storage can also be used by the contract to overwrite itself even. So you can even create contracts that rewrite themselves. And so there's no actual difference between data storage and the space that a contract uses. And so what most contracts do is they use the first 1,000 bytes of data for storing their own code, which is a kind of byte code as well. And then after 1,000 bytes, it starts storing other data like arrays and variables. And with most contracts, that will never be overwritten by the contract itself, because the contract doesn't grow or shrink, it's just a certain size. So, but you can choose. You can actually create contracts that rewrite themselves. So basically living entity contracts. I think it would be quite expensive eventually if you'd make a complex contract that does that all the time, but it can be done.
So are you involved with Ethereum in any way?
In any way? Well, no, not directly. So I haven't programmed on it myself, and also I haven't done a run of the test net yet. But I am very interested, and I like to keep a broad scope over the entire crypto market, but this one was very tempting to just jump in and forget everything else. I haven't done that, but I think I will take more time to research this because of its broad scope. And I like especially the fact that it's so universal, and just like Bitcoin, it tries to lay down a real new foundation for development.
So do you have any opinion on the way the ethers themselves are being brought into circulation?
Yes, I have an opinion on that. What I saw from the first initial development of Ethereum was that Ether also has to be mined. And it has to be mined just like what happens with Bitcoin. Now, of course, there were many people that said, yeah, well, that's great, but mining always invites the guys with the most money, because people will get GPUs and then they'll get ASICs, etc., etc. And they'll try and mine it as fast as they can. So the developers of Ethereum tried to create an algorithm that was difficult to do that with, and it's called the Dagger algorithm. The downside, however, of the Dagger algorithm is that already hints of proof are coming through that also Dagger will be susceptible eventually to ASIC manipulation. And so they've chosen already to adapt the algorithm even before launching Ethereum for real. And I think that eventually people will come to discover that there's no way you can completely eradicate that type of behavior, that even script N algorithms that are now popular will eventually be mined by ASIC-like systems. Whether
Sure,
it's a single on-chip ASIC, or whether it's an ASIC with a modular components that works together in a networking system.
Yeah, alright, so that's one thing, but it's also pre-mined for a part, right? The ethers.
The ethers are not pre-mined, no.
Well, if you invest
actually,
in Ethereum...
they are. No,
Yeah.
no, you're right. Because there's a certain amount, at least this is the last news I read on the forum, there's a certain amount that will be pre-mined and sold to get value into the Ethereum system. These will be sold for Bitcoins. They want to actually try and tie Ethereum more or less to the Bitcoin system as well. It won't be literally as a programming a part of it, but they want to financially make sure that these things start interacting. And
Right.
so they've tried a kind of stock.
Sure, and the developers get a part themselves as well.
Possibly, I don't know, but if they do, that could net them a lot of profits in the future. And I'm not sure if I'm completely, I'm not sure if I think that's a morally right way to go about it.
Well, that's why I asked the first question,
Yeah.
because for me personally, it feels like, alright, this is some kind of commercial enterprise then, and that's fine, I don't have a problem with commercial enterprises, but then it's their project. I'm not going to be part of this. You know, I might use it if it's has great functionality, but I would never give a presentation like what you're doing right now, because I'm not part of it's their project, right? That's how I feel about it. And that's one thing, and I think apart from that I won't be doing that. I think it might actually be a problem, maybe, don't you think? Because I think the strength behind Bitcoin is that it is a community project, and that everyone is like doing their part, or if anything goes wrong, there's someone who's smart enough to fix that, and if someone else needs to be done, then there's someone to do that. But with Ethereum, I fear that this is going to be like a bunch of guys doing something, and if it fucks up, well, you know, who cares? It's their project.
I would certainly
Maybe.
be one who cares, and I'd be very pissed off if it does, because I've seen several coins start in the way that you described, that they kind of create a commercial entity out of it, and then the coin kind of flops, but the guys that started it all got filthy rich. And one of the things I'm watching right now, for example, is proto shares. They're very commercial as well, and that's something I personally don't like either. So, but as far as decentralized exchanges and decentralized stock mechanisms, etc. go, of all the systems I see now, there's only two that spring out to me, which is Counterparty and Ethereum.
Alright, so but there's the other question then. Since Ethereum is open source, couldn't we or anyone just fork the whole thing and...
Absolutely, but the same can happen with Bitcoin.
And you can do different way, and can try your luck that you don't have a team that get money.
Yeah.
Right.
Thousands other people can try, so
But
it's irregular.
No, I agree that, personally I'm glad that it is completely open source, because take for example Nextcoin, NXT, and you can see that they are, yes, open source, but they use a type of embargo, which means they wait a long time before they actually release the source, so that there can be no competitors. That sounds to me a lot like the Anglo-Saxon business models we have today, which, well, let's say that they are more out for money, it seems, than for creating a community effort. So in Ethereum, that danger does exist, and so I'm watching it. It might happen. If it does happen, I will be less enthusiastic about it. However, the technology itself I'm very enthusiastic about, because also it's completely open, and if they do go rogue in that way, it's in that sense that they try to fill their own pockets. I certainly hope somebody will fork it as fast as possible and create a free Ethereum.
Right.
But as far as I can see now, they are still completely free, and the project hasn't actually booted in real life yet. So I don't know. It remains to be seen.
Which license do they use?
On the code?
Yeah.
I don't know. Must look that up. But I think they're GNU GPL or MIT, one of the two.
They are registered in Switzerland, from what I know.
Hmm?
They are registered in Switzerland, Ethereum.
Okay.
Switzerland.
In Canada.
Okay. Yeah, yeah. But I agree, it's something we have to be very critical of, because I think that's the way to keep quality also inside the cryptosphere, and not just get all these people in that just want quantity and more for themselves.
Yeah, but I mean, the whole idea is out, so even if they're not gonna succeed, I mean, we
Somebody
can,
else will, yeah. Yeah.
the hammer is made, so who is gonna make it? You know, we know how it looks like and what it does.
You also had a question?
Yeah, I was wondering about the, you mentioned the first 16 steps of the contract are free.
Yeah.
I'm wondering, so the 16 steps, I should probably not interpret that in terms of 16 code lines?
No, a
Okay.
line is already multiple steps.
Okay, right, because the step is actually, so the assembler type of language that the
Yeah.
code is, okay. But then if the first 16 steps are free, isn't there still the possibility to span the network with yeah, these micro contracts that still consume computing power?
Yes and no. Yes, in the sense that if you create a lot of micro contracts, you just create tons of them that are all different and have different unique identities, you could try and run them all at the same time and create basically a computing power attack on the network. This nobody has suggested yet. This is just my first suggestion of how I would attack the network. But I think nobody's going to take that time, because there will be so many people running this decentralized blockchain that to try and get these people's computers to go bonkers will take so much effort to do that in a dispersed way that people would rather do it in a focused way. And so a single contract makes more sense to do that with. But a single contract is limited again at 16 code steps. And that is a hard limit, and people cannot pass that. So I suspect that it's not easy to do that. It's not easy to attack the network, not easy at all to attack the network by creating dispersed micro contracts that all attack the network at the same time.
Does it work the same with so